Hello student, in the previous lecture we have discussed different type of flip-flops, RS flip-flop, D flip-flop as well as JK flip-flop. We have also discussed the timing, switching times of flip-flops. Now in today's lecture I am going to discuss an application of flip-flop, that is switching contact bound circuit. Now what is exactly the meaning of contact bound circuit? See, in all the digital system, we have to use the mechanical switch. Switches are of two types. Mechanical switch that we are using in our day-to-day life, and second is the electronic switch. But as far as instruments are concerned, end user have has a difficulty to operate with electronic switches. So he is normally use mechanical switch, the switch that we are using in our day-to-day life. Now all these mechanical switches, inside this there is a spring, and because of this spring action one problem arises in all the electronic circuits. This switch is actually known as Spst switch. Spst means single pole, single throw. We have no choice. We have to use mechanical switch. Okay, either if you are using your microwave oven or you are using washing machine or any other devices, mechanical switch is there because end user, common man, is very easily accept the mechanical switch. Now in this mechanical switch we have one problem arise because it is being connected with the electronics device like flip-flop or counter circuits or microprocessor. So we have to eliminate this problem when you deal with washing machine or your microwave oven or computer. Now first I am going to explain the internal structure of the mechanical switch, how it works. So look at this circuit. This is 5-volt supply, resistance, point A. This is your Spst switch. Now this switch has two combination. At present this switch is at open condition. In this one there is no contact between these 2 points. So this is said to be open condition. Switch is open. Now when the switch is open, what is the value of voltage at point A? So this is plus 5 volt. Plus 5 volt exists up to this point. Between this and ground there is no connection. So when the switch is open, voltage at point A is plus 5 volt. At this point you have plus 5 volt. Now this part is clear. When the switch is open, between these 2 points, when there is no junction, there is no connection, plus 5 volt is exist at point A. Okay. Now when anyone press the switch, so there is a contact between these two, and that situation is said to be a close condition. That is said to be a close condition. When the switch is closed, now at that time this plus 5 volt reaches to ground. So that means potential at point A is 0 volt. Is that clear? When the switch is closed, the path is open and this volt goes to ground level. So potential at point A is 0, and when the switch is open, this path is cancelled. This voltage is plus 5 volt. Okay, is that clear? Now in this situation, when the switch is open or closed, what is the voltage? What should be the potential? According to that, we can prepare the waveforms. So now next section is the waveform. Now look at here. We know that when the switch is in open condition, the voltage is plus 5. When the switch is closed, voltage is 0 volt. So ideal voltage at point A is like this. When the switch is open, you have plus 5 volt. This is plus 5 volt as shown here. When the switch is closed, it is 0. Now this symbol indicates unless and until the switch position is changed, it remains 0. Okay, so switch is closed. Now once again when the switch is open and so on. So this is the switch position. Now according to that, the voltage at point A, when the switch is open, the voltage should be plus 5. So it is here. When the switch is closed, voltage should be 0. This is the actual waveform, desired waveform. But due to the mechanical part used in the switch, springs are used in the switch, we are not obtaining this type of waveform. But in place of that, we are obtaining this waveform. This is the switch wave position, exactly same as this one. Now what happens when the switch is closed? When you close the switch, there is a contact with the spring and pushing and pulling action take place. And because of this pushing and pulling action, the contact is established as well as contact is removed, and that produces spike. And because of this spike, plus 5 volt and 0 volt pulse are produced. Now this pulse is actually a waveform for the next circuit, either it is a flip-flop or counter circuits or anyone. So these waveforms are obtained. These waveforms are said to be the contact bounce problem. This is unwanted things. This action occurs because of spring action. This is a spring action. This is your contact bounce problem. When you are going to combine digital device with the mechanical switch, this problem arises, and this problem is said to be the contact bounce problem. Okay, and after few nanosecond or after producing one or two spike, this pushing and pulling action is removed, and again it is at 0 volt. Again, when the switch is in open position, we don't have any problem. But when you close the switch, this problem arises. So this contact bounce problem is the actual problem of the mechanical switch. Now with the help of RS flip-flop, we are going to eliminate this problem. Let us draw the circuit of this. So this is your mechanical switch. And to eliminate this contact bounce problem, we are using RS flip-flop. When this is a situation, that is number 1, high condition. When the switch is here, you can say it is a low condition. Okay. Now suppose switch is at present at this condition. So that means plus 5 volt is connected here. So S is 1 and R is 0. So that means Q is 1, Q bar is 0. S is 1, high condition, Q is this one. Now after that, when this connection is broken, okay, and if you switch to this position, okay, so at that time there is a transition. When there is transition and your mechanical problem arises. This is your mechanical problem. Now at this time what happened? This becomes 0. For a fraction of second this becomes 0. So S is 0, R is 0. S is 0, R is 0 means circuit is in no change condition. So Q is not going to change. So your Q remains as it is. So in this way we eliminate this problem, because in mechanical switch this type of spikes produced, but here 0 0 means flip-flop retain the previous state. So this mechanical problem is eliminated with the help of RS flip-flop. In second position, suppose we assume that switch is in lower position. When the switch is in lower position, S is 0, R is 1. And at that time, Q is 0, Q bar is 1. Now when change occurs, transition takes place, what happens? This is going to lose the contact. And when it going to lose the contact, this become 0. So 0 0 means flip-flop retain the last state. So as this is 0, it remains 0. So by using RS flip-flop, very easily we can eliminate the mechanical bounce problem. This problem either at this end or at this end can be eliminated at the output. So in any position, either it is at high position or at low position, if due to mechanical switch problem, spring action problem arise, it is eliminated by RS flip-flop. This is application of RS flip-flop. So in exam they can ask you, give an application or discuss the application of RS flip-flop or contact bounce problem, you have to explain this one. Okay, so theoretical part of this chapter is over. Now today we are also discuss few short questions related to this chapter. The first question is, what is flip-flop? Flip-flop is a bistable multivibrator. Another name is latch, a circuit that has only two levels, 0 and 1. So what is flip-flop? Bistable multivibrator or latch which has only two levels. Okay. Second question, explain the term Asynchronous. Asynchronous means independent of clock pulse. It is independent of clock pulse. Without wait for the clock pulse, circuit change the state. In the first and second lecture, I have discussed this point. Asynchronous flip-flops are not good one because the delay time is very high. They are independent of clock pulse. Unwanted pulse known as glitch also occurs in this one. So we have designed a synchronous counter. What is synchronous circuits? Synchronous means a circuit that change the state in presence of clock pulse. In coordination with the clock pulse, circuit is going to change the state. That is known as synchronous. Synchronous circuits are better than asynchronous circuits. Okay. Then setup time, hold time, and propagation delay time. We have discussed this topic in the previous lecture. Setup time, that is the minimum amount of time that data must be present before the clock pulse arrives. Hold time, the minimum amount of time that data must be present after the clock pulse arrives. Before, after. And delay time, propagation delay time, the time required by the internal devices like diode, transistor of the circuit to change the output after the input pulse applied. What is the timing in terms of nanosecond for this one? We have discussed in the last lecture. 15 nanosecond, 5 nanosecond, 10 nanosecond. Okay. Then yes, one more question. One IC is given. IC 74LS279 is a quad latch. Then what is the meaning of quad in this one? The quad means there are 4 flip-flop inside this one. 74, that indicates it is a TTL IC. It is a series name, that is a TTL IC. Now the next question they can ask, why is NAND gate latch considered active low? See, we have two types. NAND gates are active low, NOR gate is active high. The reason is straightforward, because L is 0 at either input S or R is required to change the output. See, in NAND gate, when any input is 0, output is 1. So that is why when L is 0 at either input, S or R, it is required to change the output. So when any input is 0, so that is why it is known as active low. Similarly, the question is asked why NOR gate is said to be active high. So when H is 1 at either any input, it is required to change the output. The last question, what does it mean to say that a flip-flop is transparent? Answer: the condition that exists when the flip-flop output changes immediately after inputs may be R, S, J, K, D change states. What does it mean to say that a flip-flop is transparent? So the condition that exists when the flip-flop output change immediately after the input is applied without the delay time, that either it is SR flip-flop, JK flip-flop or D flip-flop. When the input is applied, output is immediately changed. That is said to be the transparent. Okay, that is the meaning. Okay, so here is the end of your second chapter. The syllabus of your this paper is over. So from the next week, we are going to discuss another topic, and I will give you an assignment of this chapter after 1 week, but only few students has submit the previous assignment. So before that, within a week, you have to submit the previous assignment. Okay, thank you.